Next presentation is about simulation-based production planning and multitask, multi-stage yacht manufacturing process. It will be presented, well, this is a joint presentation. It will be done by Dave Buxton from DSE Consulting from the UK and Luigi Manca from Fade Dynamics from Italy.
Good afternoon, everybody. Me and my colleague Dave will talk about one business problem we solve with AnyLogic and with multi-method simulation modeling. Okay, just a very quick slide on the companies. We are Fade Dynamics. We are based in Italy, as my colleague told before. And Dave is from DSE Consulting, he's from UK. And we collaborate since 2011 in many projects. These are some of the customers we work together in. DSE is mainly focused on developing modeling and simulation instead of FD is more focused in business consultancy. Due to the short time that we have, we will focus the presentation on the innovative aspect that we study for this model. So I will shortly introduce the business problem in order to save much more time as possible to the practical demonstration that we will done by Dave. Okay, so this is what we are talking about. So a wonderful boat, luxury interiors, the sea, the sun. So in other words, a really dream. But many of you should ignore maybe that these dreams came out and it's the result of a lot of nightmares. A lot of nightmares, mainly, fortunately, only for the director of production. And mainly these nightmares have their origins in the unique combination that the production of a yacht has in the marine industry has, and the complexity that we will find in it. Production uniqueness, now some very small bullet points. A complex process flow, does it mean a huge amount of tasks and small components that have to assemble it together and fit it together on bigger yacht parts that have to be combined in different phases and different times. Moreover, this complex process flow is complicated by the logistics. As you know, moving a part that is 20 meters longer and 5 meters tall, it's not easy. And if you don't move this part in the right at the right time, in the right position, you can risk to create a physical bottleneck in the plant and slow down all the operation that you have to do. Moreover, you have limitation in space. Yachts are bigger, but you can put an horde of people in working on the same boat. So you have to be very, you have to control very well the operation, not to have 10 carpenters, 12 mechanics on the same boat. You cannot do that. So we talk about inflexible, high-skilled workforce trades. That it means that we have more than 7 different trades that do different works. It's like building a house. So you need an electrician, you need to have a carpenter to make the furniture and the interiors. And moreover, you have not only to build a house, but you have to build also a house that is moving on the sea and has to be safe. So a lot of high-skilled trades. And you have to do that with high quality and handmade finish. So you have to give the customer to have something that is tailor-made for him. And it's not easy, also because you have to always be in fighting with the costs. Okay? Also, because assembling a yacht is something that takes more than 6,000 hours per yacht. So a huge amount of work, of working hours, mainly done by people without any robot or any other equipment. So going deeper into the case, talk about just very little to the market. It's a competitive and mature market where we are in Italy, and Italy has a proud history in building yachts. As you can see, this is the data from 2011 was the order book of all the boat industry. And as you see, Italy is the double than the second one, that is Netherlands. So you are in a competitive market, in a competitive country, the most one. Going again, we are talking about motor yachts, and motor yachts, as you see, are the 75% of all the orders. And this is a problem also for luxury items. There was the crisis. So after 2008, we had a downturn of the market. We had to be more aggressive. So that was the background that was figured to our customer. Our customer was a new entrant in the market in the sense that it was a new brand of a very big group and with a very well experienced management. And so they know very well that if they want to survive to this market, they had to be very good in design. So they immediately win a lot of prizes for the design, but this was not enough. They had to have new manufacturing ideas. They wanted to, I can say, they wanted to win over their competitors on the price. So I can say, so they wanted to be more competitive, and more competitive in the price means that they had to implement new techniques, new innovative lean manufacturing techniques in production, and to control them very well. So they had the feeling that what they need was to control the production and to control the huge amount of working hours with a new planning tools. Not the normal planning tools, because they need a new intelligence approach. A normal scheduler that you can find into the market has too much details and needs a lot of information to work in a good way. So they wanted to use instead this planning tool for the strategic view. Just at the beginning, during the budgeting, they wanted to know how to balance and the delivery dates required by the final customer. Obviously, all the customers want the boat before the summer. And but you cannot produce all the boat in January and do nothing until the next September. So you have to be very good in balancing the production. And these are two of the outputs that we have. So a Gantt made in Excel. This is not the real, this is just a makeup. With all the production, so they had the impressive view of what they have in the plant at a certain times. And this is an aggregate diagram that shows how the allocated people into the plant is versus the required people. Okay. Now I want to see Mr. Buxton, that we show you how we answer to these two questions. Thank you.
So, excuse me, that's probably the first time Luigi's called me Mr. Buxton. It's very, very polite in front of the today. The solution that we put together was based on the concept of test and learn. Clearly, one of the core things through simulation is the idea of what-if analysis. We weren't trying to optimize. We weren't trying to deliver this customer a prescriptive solution. We wanted to give them a tool which would allow them to understand exactly how their factory performed, what were the constraints within their system, and what they could do themselves in order to improve the situation. So we've had so we have a concept of an AnyLogic model living inside another world. Now, DSE itself, as Luigi has hinted, comes at simulation probably from a slightly more technical perspective than Luigi. Luigi gets to do all the nice fluffy stuff with the client, and I get bogged down in the weeds of the code. So what we have here is a solution front-ended by Excel with a database sitting behind that, and the AnyLogic model interacting with the database to run a simulation based on the user's input, and we're going to output some results straight back to the Excel. The user is then going to use that in order to decide what to do next. So we've got an iterative approach to learning. They're then going to refine the information, the inputs. We're then going to suck that back into the model, and we're going to do a follow-up run. But we're always going to keep the user in the environment of the Excel so that they're looking at this from a decision supports perspective. Now, one of the what we're not going to do is go through the model in great depth, but one of the innovative aspects of this model was the agent-based approach to the production planner. Now, from the earlier slides, if you can remember back 3 or 4 minutes, and some of you are still awake, although this side is less awake than that side. You can see if anybody's even spotted what I've said there. Yeah, no. We've got a manual, and I think that's quite critical. We have got a manually led process here. So the manufacture of these boats doesn't require a huge, great selection of automated machinery. Now, the difference between using a person and a machine is that a machine is very controllable. Yep. We know that a process takes 3 minutes plus or minus 15 seconds, and it breaks down once per 15,000 hours of operation. Those are things in which we can simulate, and we've done a lot of simulation in production planning, and come up with the optimum solution. In a manual-based system, such as this one, what you're dealing with are people. Now, people aren't as predictable. One day, it may take the guy 3.5 minutes to turn the spanners to tighten up a certain bolt or to tighten up the motor. The next day, it might take him 15 minutes because he's chatting to the guy next to him about what happened at the weekend. Yeah, we also have more unpredictability about when people arrive at work and how long they're at work for, and sickness. So bearing in mind we've got a manufacturing process taking over 6,000 manual labour hours. Yeah, we've got a huge variety of different areas which can overrun, get delayed, get cancelled, get put off. And that can be further compounded by delays in the arrival of parts or specialist machinery, or even the major systems that go into the boat, so the huge extrusions for the hull. Now, when you look at this system from a mathematical or an algorithmic perspective, it looks very much as if it cannot work. Yeah? We cannot meet the production targets to the level at which this factory is currently outputting. And the reason that it does work is that we have a human in the loop. So we have a production planner who's a very intelligent, very well-paid production planner because he's very good at the art that he does. He manages, through his intelligence, his skills, and his experience, he's probably worked in the marine industry for his entire life, to get that factory to a point at which it produces yachts pretty much according to the schedule. Maybe not to the schedule that was set out right at the beginning, but he gets it out on time. That's probably correct, yeah. And that is what he... And so in order to capture this as a planning tool, we needed to incorporate some of the decisions that production planner is making on a day-to-day basis to react to the situation which he may find in front of him. Okay, so we can imagine it's Monday morning, he's on a critical deadline, he's expecting 75 people to walk into work that morning, however, only 68 do, and of those, 5 of those have got really bad hangovers from a weekend. That means that 7 of the processes might get delayed that day, and a further 15 can't be started. Yeah. He, by the end of the week, will have managed to manipulate the plan to get those yachts out the door, so he will have caught up. Yeah, and there's a great deal of intelligence that goes into that. So to model that within our system, we adopted an agent-based approach to this aspect. So in principle, we've got a discrete event model. We're modeling the process of yacht production, but we're supplementing that through the intelligent use of an agent with some intelligent rules that capture how he manages to make this chaotic system, which when you look at it from standing above the factory floor, you think cannot work. There is no way that they can get these processes out. These processes are interlinked, they're concurrent, they use multiple trades, they're contingent on each other, they have a sequence in which they have to be done. It's an impossible balancing act. Yeah? But we're trying to do that. It works in the real system, and we're trying to capture that complexity by using an agent-based approach. And to put that together, we've adopted it, for those of you who come at it from a process simulation perspective, the approach that we're using is very different. So we do go and take the production planner out for a pint. We do sit with him in the coffee shop, and we do try and talk him through exactly what he does, which we then capture back into decision rules, and we implement within code. At the end of the day, it all comes down to a bit of Java code, but we're trying to use a very constructivist approach in order to understand exactly how this very critical person, player, in a discrete event system influences and makes the system work. And then in addition to that, because of the concurrency of the processes, and the way that the system is structured, so we're very contingent on process X finishing at 9 o'clock one morning to move into process Y, and they require different trades. Okay, that we found that the existing AnyLogic enterprise library was not sufficient. It could not handle that complexity. So we spent some time partway through this project building ourselves what we've called a concurrent processing object, which we've subsequently found useful in many different projects, that allows us and interacts with our simulated production controller to manage the concurrency of certain tasks that may last differing times, that may get rescheduled partway through, and will be requiring different trades at all times. Okay. And finally, the concept of test and learn, which is not innovative in any way, shape, or form, but for getting people into the domain of simulation. They really enjoyed the idea that we're giving them a descriptive solution. Yeah? So we're giving them the information that improves their gut feel decision making. We've got to remember that we have a real production planner who's going to be using this tool day in, day out. We're not trying to take him out of the system, but what we're trying to do is give him better information in order to make his decisions. So part of the information that we're giving out that is an output of the simulation is what we would expect, which is what Luigi was asking for, which is a production plan. So we are trying to tell this factory what it should make on which day. Okay, so we have got some aspects around that. But in addition to that, hopefully it comes up, we've also got, have we got a pointer? Aha. Does it work? So part of the test and learn is the fact that we can run in two different modes for the simulation, the constrained and the unconstrained. So we envisage the use of this simulation to be in unconstrained mode first, where we do not constrain the role of the production, the resources available to the production planner. So in essence, our production planner doesn't have to use any intelligence here, because if Bob doesn't turn him in on Monday morning, he can just request extra resources. So we're imagining there's an infinite availability of staff. And that gives us the idealized production plan, which was the previous slide, okay? And then to achieve that, the ideal number of people. So that's the first beginning of week 1 to 20 by the beginning of week 2 to 27 by the middle of week 3. Nope, can't do that. That's impossible. Resources aren't available. What I'm going to do is try and balance and smooth my plan. Yeah? So I'm going to say that we'll have 16 people all the way along. Now, this piece of information becomes the basis of our second run mode. So when we run in the constrained form, we're going to take this information into the simulation and show the effects of the decision maker's actions on the production plan. So we will see the difference in what is possible to make within the factory in this sort of diagrammatical format. Okay, so if I try and do a quick demo. And I'm regularly advised never to do a live demo. Hold on. I was going to just drag it on when it comes up.
Okay.
Think it would be okay?
Yes.
Okay, so we've obviously got a range of different constraints that we can put together. Okay, and first of all, we're going to run it in unconstrained mode, in scheduling mode. And I can't find my cursor. So at this point, it's pulling in all the information that our production planner would have specified in terms of yacht numbers, production tasks, the duration of each task. And we're going to see a nice physical representation of our yacht. We can see all the processes that are going on and the number of people that are currently assigned to that yacht. Okay, what you'll see is things being glued together. So that's a... Okay, that's a... What's that called? What's that bit of the boat called? That's the hull, and that's the bridge, the fly. Oh, the interior module. Ah, yeah, of course. You can tell that we're on the same wavelength, me and Luigi. As collaborators, we're just there. However, you will see that we've gone through our production plan. We've got one yacht left, and that's going to take us some time to take. Yeah, that's a prototype boat going out the door. So if we then go back, and I've lost the cursor. If you spot the cursor, there you go. And when it's finished outputting the results, we can run it in the constrained mode. What we will now hopefully get, if this is going according to plan, is a very different picture now. So visually, you can't really see what's going off, but what we have got is these red indicators here telling us that we want more people than we're allowed. So now our intelligence within our production planner is really kicking in. Now he's got a problem, and he's having to go through a range of decision rules, which we've modeled as action charts. Okay, if we have a look down here somewhere, hidden away, and way too big. Okay, so we've got a series of action charts. We've reduced his job to action charts, which he thoroughly enjoyed, that are going to help us come up to a situation where we can make things in this factory. And if we run this further forward, you would see that we've got a lot of, in this situation, we haven't got too many constraints on a regular basis, but the length of time these yachts are taking is contingent on the planning rules and the intelligence that we've now captured in our production controller. So I can see Tim's getting nervous when I promised him that it would be a quick presentation. But he's fortunate because we are on the concluding remarks. And Luigi can help me with some of these if required. We definitely had the concept of a happy learner. The objective was to give a test and learn tool with a happy customer at the end of it. He was happy because he got something that he could play with, a descriptive tool rather than a prescriptive tool, and he could immediately see that there was opportunities for resource utilization improvement. So we hit both factors for him, really. As good consultants, we made sure that this project provided the basis for the follow-on work, and that's always the loop that we try and do as consultants, so that there's always a drip feed of money coming in. And we're planning to extend the tool into other aspects of the supply chain. So getting more into realizing that this model is not just constrained by people, but there are other companies out there delivering parts in that can affect how our planning goes through. Commercially, we have been taking this tool around a little bit and received some commercial interest in applying it to other areas which are very much human process driven, where there is the long variety and the problems associated with that. And for us, for both of us, but particularly for DSE, because my company is very much based around the inclusion of an agent-based approach into simulation, is that we have got evidence that the use of agents for complex decision-making and complex manufacturing systems does deliver a real, tangible, demonstrable benefit. Okay, so thank you for your time.
Well, questions?
See, I told you were all asleep.
We killed them.
Yeah, I was wondering, I mean, you showed us the direct presentation, but in terms of runtime length, is it actually the case that your clever guy at the manufacturer can click it and 10 seconds later he's got a result that he can then reiterate about? How long does it take for?
Yeah, pretty much. Yeah, we've got a runtime of less than a minute. So he can try out a whole different variety of resource allocation scenarios and refine to an optimum plan, optimum in a human sense, but he can test out the things that he thinks are feasible and the way in which he can possibly recruit. Or he was using it to look at how he could balance carpenters who can also do fitting. Like there's some aspects where trades, electricians can't be a mechanic, but mechanics might be a fitter. Possibly. I don't know, something along those lines. So he was playing around with the idea of shared resources and shift lengths and the like. So yeah, we're trying to give him a really rapid simulation tool. Yeah, something that you can do a year or 2 years really, really quickly and just spend 5-10 minutes at the beginning of each morning if he wants to revise his plan.
Also because he has to speak and to talk with a sales guy that tell him that this scenario is not okay because the customer wants the boat in this period. So try to do your best and change all the other boats if you want, but not this one. So an optimization could be is not useful. No. It's just scenario simulation.
I was wondering if you had a chance to compare with the decisions made by your model compared with the production planners, how close or how different it was?
One thing that probably hasn't come clear in that simulation was this was for a future factory. Essentially, the factory was just being constructed. They'd moved from another site, so we were using this. Partially, the project kicked off in order to design and define how their manufacturing should be structured. At a technical level, if you want to say, at a unit test level, we did go through some validation with the production planner where we looked at what his inputs, if he was set with this range of input data, what might he then try and, what would be his reactive decision. And we were getting some similarity between what the model was saying and what the real production planner would make. But it was very subjective. It's not got the academic rigor that you would possibly want if you were going to turn this into a PhD. And in essence, I guess, like I say, it's a very chaotic system. So there's always, let's say there's 5 boats out there, 50 people. He's got a lot of different ways in which he could reassign the staff. And we weren't looking to optimize the staff allocation that day. We were just looking to say, okay, then what, in judgment terms, would be the best thing for the person to be working on. So partially, but probably not up to academic rigor standards.
I suppose there should be several tools specialized for the purposes you made this model for, or am I wrong?
If we were just to do the discrete event simulation, then Tim should close this. We could possibly do it quicker and faster in another tool, a purpose-built tool. So with the possible inclusion of the agent-based modeling aspect, so this really complex situation, those tools just haven't got the breadth or strength or depth in order to get into that level of algorithm-based decision making. So AnyLogic really is one of the key tools or core tool available to us to do this type of simulation, unless you want to start coding it from scratch or using Java or Repast or some free tool, which is just from a consultant perspective, a waste of time because AnyLogic is a rapid development tool. It's very quick to do these types of models, really, in reality.
Okay, I see. Thanks.
Possibly a techie question, but did you embed AnyLogic into Excel, or did you kind of call AnyLogic from Excel?
AnyLogic is called from Excel, so we pass the data back to Access in this situation, and then we pass some parameters straight into the simulation model through the Java bat file, in essence, that's created when you compile it. And so the user just presses the go button, and from his perspective, he does still get the pretty picture. I mean, as anybody who's developed simulation models commercially knows that, like, the big selling point of simulation is the graphics. Yeah, as much as we would like to say it's all about the model, it's all about the clever algorithms, it's actually as much a sales tool to take evidence to other people to convince them, and part of that is the visual display you put around it. And so they get the visuals, but then we go back into Excel and they do all their analysis and they do all the examination of the data in the Excel.
Well, thank you for the presentation.